And I do have a slight change from what was originally planned in the agenda. So as you can see, I don't have species composition change up here. But instead, I'm gonna give a brief introduction to the climate smart conservation planning work that we're engaged in at Point Blue, and some of the research tools and projects that we've developed to address climate change on rangelands.
Alicia?
Yeah.
You're showing your presenter view. Can you switch
sorry
it to
about
the
that.
presentation view? Thanks.
Does that, oh, I knew I was gonna mess something up here.
That's good.
Okay. So just briefly, an overview of Point Blue. Since 1965, we've conserved birds, other wildlife, and ecosystems through science, partnership, and outreach. And we work in 6 priority initiatives to collaborate on climate smart conservation actions that will sustain thriving wildlife and human communities well into the future. We identify and promote nature-based solutions that will reduce greenhouse gas emissions and improve the ability for humans and wildlife to adapt to a rapidly changing climate. Within our Working Lands program, we partner with land stewards, ranchers, and managers to ensure that agricultural landscapes provide ecosystem services that support the needs of people and wildlife. And we specifically aim to maximize co-benefits on these working landscapes, including wildlife habitat, climate mitigation, and agricultural productivity. So in order to manage these landscapes for multiple benefits, we first need to understand the status, direction, opportunities, and vulnerabilities on California rangelands. And the Rangeland Monitoring Network helps us to do that. Under the RMN framework, we partner with local ranchers to establish baselines for monitoring change, provide information to landowners and ranchers to guide management decisions, and evaluate the ecological effects of rangeland management practices. Since 2014, Working Lands biologists have used a standardized protocol to collect information on birds, plants, and soils from over 500 unique locations on 100 ranches across the state. And so based on this initial data, we know that privately owned rangelands in California provide important habitat for birds. Over 90% of California partner in flight, grassland and oak woodland avian focal species have been detected on RMN ranches. And the Central Coast in particular is important for grassland birds, which we have learned earlier today that this is a group of birds that are in severe decline in California and across the nation. We know that the rangelands that we're monitoring are largely dominated by annual grasses, but they still harbor a number of other important functional groups, including perennial grasses. And in general, they're very species rich. We know that, based on our monitoring from the last 7 to 8 years, we know that California rangelands are losing soil organic carbon. Among our RMN rangelands, we saw a 2 to 2.5% decrease in soil carbon stocks since 2015. And the Central Coast in particular lost more soil organic carbon from the top 40 centimeters of soil than other regions that we monitor. So once we know where we're at and have prioritized areas for active management, then we need tools to help us get to where we want to go. And we need to make sure that those tools, they're durable and resilient in the face of climate change. We lean on climate smart principles to help us with this, and have been innovating on those principles and conducting additional research on rangeland carbon sequestration to help us fill out the picture. So I'm going to provide a brief overview of Point Blue's Climate Smart Restoration Framework and some of the research projects we're currently working on. So when we talk about making ecological restoration climate smart, we mean designing restorations in a way that will make them more resilient to the consequences of climate change. Or another way to look at this is we want to design restorations that will allow habitat to adapt under different future climate change scenarios and provide multiple benefits for both wildlife and people. So we've created a framework to guide the development and implementation of climate smart restoration that consists of these 7 guiding principles. Where this framework most differs from traditional ecological restoration are primarily in these 3 principles: look forward but don't ignore the past, build ecological insurance, and build evolutionary resilience. So by looking forward and identifying possible climate vulnerabilities, we can build in ecological redundancy and resiliency into our restoration projects. So how this might play out during a restoration project is that based on the project goals, climate vulnerabilities are identified. And based on those climate vulnerabilities, actions are identified that will build in resilience and ecological redundancy. Building upon the framework, the Climate Smart Restoration Framework, inoculum supported restoration, or ISR, takes into consideration the below ground community as well to enhance restoration outcomes in light of climate change. So most plants associate with below ground fungal partners with whom they exchange resources. They're critical to plant survival and growth and the carbon cycle, including long-term soil carbon sequestration. So we built on the beneficial relationship that woody plant roots form with ectomycorrhizal fungi. And with a hotter future in mind, we collected local fungi and fungi from warmer, drier areas and added them to the soil during restoration plantings. What we wanted to know is, does this approach even work? Can soil inoculum increase plant ectomycorrhizal associations, survival, and vigor? And does inoculum from warmer, drier climates increase plant survival and or vigor compared to local inoculum? So over a 2-year study, we found strong evidence that ISR more than tripled the odds of survival in arroyo willow and coastal live oak, and that these trees also had higher rates of root colonization by ectomycorrhizae. We also found that the odds of acorn germination doubled for both of the oak species in our study. And given our initial results, we're excited to incorporate the technique into our restoration work that we do at Point Blue, while continuing to test and refine the approach. Another innovative restoration approach is our Drought Tolerant Oak project, which asks whether and how we can steward blue oak populations so they're resilient to climate change by creating a living seed bank of individuals that are more tolerant to hotter, drier conditions. So in partnership with Working Ranches, we collected acorns from the southern edge of the Blue Oak Range, where climate change and drought is causing extensive mortality. And we planted them at 12 northern ranches where we also collected and planted local acorns. And we evaluated seedling performance after the first growing season by noting survival, height, and indications of leaf disease and herbivory. Overall, translocated acorns survived well at the northern ranches, but had lower survival and growth relative to the local acorns. Yet the seedlings from the translocated acorns experienced lower levels of leaf disease and herbivory, traits that could provide an adaptive advantage in a drier, hotter future. The substantial early survival of these translocated seeds suggests that field gene banking offers an effective means of maintaining genetic diversity that could be critical for future climate change adaptive restoration. And we plan to continue to steward and monitor the seedlings long-term to confirm survival and evaluate evidence of local adaptation. And then lastly, the Rangeland Carbon Management Project. Overall, this project aims to help us better understand and communicate the ability for rangeland management practices to sequester and store carbon across California's rangelands. This project has three main outcomes. First, to create monitoring methods to track carbon response to commonly implemented rangeland practices. And for riparian restoration, silvopasture, and range planting in particular, we will measure carbon change over time since implementation and estimate the long-term contribution to climate change mitigation. And then using the data collected from outcome number two, we want to improve predictive models that are currently contributing to policy and implementation. So this is the full suite of practices that are included in this project. And these are practices that we commonly see implemented under state and federal funded programs. So we hope by looking both to the past and the future, we can address current needs related to managing soil carbon on California's rangelands. So that was a very brief overview of some of the ways Point Blue is engaged in climate smart conservation planning on California rangelands. And I didn't have time to go into much detail, but welcome you to follow up with me later, and I can get you in contact with the right person.
Great, thank you, Alicia. There's a lot of great information there. If anybody has any questions for Alicia, please put them in the chat and she can address those there. And if you can put your contact information as well, Alicia, that'd be wonderful.